Hey friends, welcome to Magnus tutorial section, Econ 44 for econometrics. And today we are going to walk through some past questions, questions on endogeneity. But before I start, I'd like to admonish each and everyone watching this video to kindly like, subscribe, and share so that anytime we post a video of this, you have easy access to it. And I hope you find today's tutorial very useful. So let's kickstart. This is a question from 2017-2018 econometrics interim assessment. Question 4. So our first question, we are solving question 4. A, it says that what are the consequences of estimating for regression model suffering from the problem of endogeneity by ordinary least squares? Okay, so there are basically two consequences. Okay, we have the model will suffer from estimate biasness. Another consequence is that it leads to inconsistent estimates. Okay, so let me just show you the results. So that's question 4, interim assessment. Okay, good. So these are the consequences. 1, we have bias estimates, and 2, we have inconsistent estimators. Okay, so that's it. So they are basically two consequences. We have least bias estimators and we have inconsistent estimators. Okay, so let's go to the next question. The B says that instrumental variable estimation technique involves a search for a new variable called instrument to replace a covariate suspected to be suffering from the problem of endogeneity. What characteristics should a variable possess to qualify as an instrument? So they are basically asking us to give the characteristics that a variable should possess in order to be qualified, or in order to qualify as what, an instrumental variable. Okay, same way or likewise, we have two characteristics. One of the characteristics is the variable should be uncorrelated with the error term, and another characteristic is that the variable should be correlated with the endogenous explanatory variable. So let me share the solution to you that you see what I'm talking about. So these are, let me zoom it more. These are basically the characteristics. 1, the variable must be uncorrelated with the error term, just as I said. And another characteristic is that the variable or the instrument must be correlated with the endogenous explanatory variable. So these are the characteristics of a variable, or the characteristics that a variable should possess to qualify as an instrumental variable. So yes, that. Let's move to the next question. C. We are actually focusing on the A, B, and C. The C says that given y to be equal to x beta plus e, and z is an instrument, derive the instrumental variable estimator and prove that the instrumental variable estimator is unbiased. Okay, so now what this question is trying to say is that there has been an occurrence of endogeneity in this regression model, and for that matter, they introduced z as an instrumental variable to correct the problem of endogeneity. Okay, so the consequence is that it leads to bias estimator and bias inconsistent with estimator. So we want to solve that problem. Okay, so they introduced this variable to solve that problem of endogeneity. So we are being asked to derive the instrumental variable estimator and prove that the instrumental variable estimator that we found is unbiased. Okay, so let's try and walk through the solution. Okay, let's walk through the solution. Hope you find it very useful. So I'll be doing some sort of writing here. Okay, so this is my worksheet. Let me zoom it. So now we're giving the model in this form. We're giving the model in this form. Y we're giving the model in this form. Sorry. Okay. So we are giving the model in this form y to be equal to x beta plus e. So I'm labeling this my equation as what? Equation 1. Okay. Now let's go back to the question. So they are saying that they introduced, the thing is that z is an instrument. So they introduced this instrumental variable, which is z, to correct the problem of endogeneity. Okay. So now let's continue with what you are doing. So if z an instrument, okay, is an instrument. So this is the short form for an instrument. Okay. So if it's an instrument which was introduced into this equation, then it means that both z and and if z and x are independent. So if z and x here are independent here, then it means that our new model will be in this form: x beta plus z beta z. So let me name this one as beta x and this one as beta z, plus my stochastic error as e. So let me label this equation as what? Equation what? 2. Okay. So I want to go through this solution step by step so that you understand. So they introduced this variable z, okay, to correct the problem of endogeneity. So this variable is an instrumental variable, okay, and if x and z are independent, then it means that we are going to get a new regression model in this form. So if this is my equation 1 and the new regression model, I name it as my equation 2. Okay, so we are going on trying to derive the instrumental variable estimator. Okay, good. So let's continue. So we will try and generate the metrics for this new regression model this new regression model. Okay, so now we can recall from last semester that we could have gotten an s prime x matrix for this one. Likewise, would we be able to get an x prime x or x prime z matrix for this new regression model? So let me try and do some sketch here. Okay, so the new independent variables that we have x, we have y. Okay, so I write it row wise and I'll write it column wise too. So I have x here, then I have what? Y. So then I'll do my mapping. So this x by this x will give me what? So let me try and draw some lines. Good. So this x multiplying this x will give me xx. This mapping to this will give me what? Xy. And this mapping to that will give me yx. And this mapping to this will give me what? Y. Sorry, it's supposed to be z. So this part is supposed to be z. This very part is supposed to be z. Sorry, let me wipe it off. This very part is supposed to be z. Okay. This side was z beta that. So this side is z, and this side is z. So I'm going to get this side to be z. Let me do the mapping well. Good. So now this mapping to this gives me SS. This mapping to this will give me XZ. And this mapping to this will give me what, ZX. This mapping to this will give me Z. Okay, good. So I'm trying to generate the matrix. So in matrix form, this XX, in matrix form, we say this as what, X prime X. And this will be what, X prime Z. This one will give me Z prime X. And this will give me Z prime Z. Okay. So now, let me wipe this thing off so that with this idea, you would be able to generate the matrix. So, good. So now, we generating the matrix, you have, so generating the matrix, we are going to get X prime of X. Now, on the first row, I'll get X prime of Z. Then the second row will give me what, Z prime of what, X. I'm going to get Z prime of Z. And what am I estimating for? Beta X and beta what, Z. So this will be my estimate. So I'll get beta X cap. So I'll get what, beta Z here, cap. This is my estimate. And this is supposed to be equal to my output, which is what, X prime of Y. Then I'll get Z prime of what, Y. Good. So I've been able to generate the matrix here. So this is my matrix form for equation number 2. Okay. So we try and multiply this matrix in order to expand it. So we know that we do multiplication of matrix by row and column. Okay. So first row will multiply this, and second row will also multiply this so that we expand it. Okay. So let's walk through it. So first row multiplying this, so this, it will be this times this plus this times that. Okay. So X prime X multiplying beta X cap will give me what? So I'll end up getting X prime of X times beta X cap plus this multiplying this. I end up getting X prime Z all in brackets times beta Z cap. Okay, and it will be equal to the output. This is my output, X prime of what? Y. So I'm naming this one as my equation 3. Please hope you are all following. Good. So now the second row, I'm going to multiply this by the estimator here and this by the estimate here. So Z prime of X multiplied by this will give me, so I'm going to get Z prime X multiplied by beta X cap plus Z prime of this, give me Z prime Z multiplied by what? Beta Z cap. And my output is what? Z prime Y. So I'm labeling this as my equation 4. Okay, so I've expanded the matrix, I've multiplied the matrix, and this what I've gotten. So I've gotten equation 3 and equation 4 out of this. Okay, good. So we are still generating it. Okay, so let's go back to the assumptions. So let's go back to the assumptions. So now we saw in the the characteristics. So the characteristics that will make a variable qualify as an instrumental variable. The second part of it says that the instrument must be correlated with the endogenous explanatory variable. Okay, good. So that's what we are using. So you should take this characteristic more important. You should take a critical look at it. So we are going to apply this here. Okay. So now, if they are saying that, so we'll go back to our worksheet. Let's go back to our worksheet here. So if one of the characteristics is that the variable or the instrumental variable should be correlated with the endogenous explanatory variable. Okay. So which one is the endogenous explanatory variable? That's the X we have here. So we had a problem of endogeneity in this model. Okay. And for that matter, they introduced this Z to solve this problem of endogeneity. So if you are looking out for the endogenous explanatory variable, then it's this X here. So it means that there should be some sort of correlation between this Z and X. Okay, meaning there should be some sort of relationship between this Z and X. So when it comes to equation 2 here, these are new independent variables here. So if there is some sort of correlation between Z and X here, or relationship between this Z and X, and this Y depending on this X and Z to assume its values, then in fact there will be some sort of relationship between this Z and this Y too. Okay, there will be some sort of relationship between this Z and this Y, and there will be some sort of relationship between this Z and this X here. So the dependent variable should be correlated with, the instrumental variable should be correlated with the endogenous explanatory variable. So it means that there should be some sort of relationship between XZ and what ZY here. So in effect, so since there should be some sort of relationship between the explanatory variable and the instrumental variable introduced, then in fact it means that my x prime x and the z prime z and that of x prime of y will map to 0. Okay, so we are looking out for the instrumental variable estimator. So if x prime x is 0, here will be 0, and x prime y is 0. If I'm looking out for the estimator, that's the formula to estimate for this beta cap, I'll end up getting what 0, because this side will be 0, this side will be 0. So making beta z cap the subject, I would have to divide through by this, and 0 divided by any number is 0. So we are not going to consider equation 3. Okay, so we are going to consider equation 4. Okay, so we're considering equation 4. Z prime z here is going to be 0. So in fact, we are just left with this. So from equation 4, so from our equation 4 here, we are going to get our new equation to be z prime x beta x cap to be equal to z prime y. So let me name this one as my equation 5. So this is the new equation that we are getting here. So you are looking out for the instrumental variable estimator. Okay. So the instrumental variable estimator means we should get a formula which will help us estimate for or find or solve or compute for our estimate, which is what beta cap here. Okay. So we want a formula for beta cap. So it's a matter of we making what beta cap the subject. So we making beta cap the subject. So beta cap the subject, beta s cap the subject here. Then it means that I would have to divide through by this, and I'll get z prime x inverse z prime of y. Okay, so this is our instrumental variable estimator formula. This is what they asked us to derive. Okay, so this is how you go about it. I hope you find it useful. So let me quickly run through the solution, what I have here, so you all get it. So now Given the regression model, this, so that was what it was giving the question. So if Z is an instrument and X and Z are independent, so that's what we saw in the worksheet. This is going to be our new regression equation model. So just as this as our equation 2, that's the same thing we have here. Okay, so regenerating the matrix, and I walk you through how I generated the matrix. So this is our matrix. So this is what we saw here. Okay, this is what we saw here. Good. So we want to expand the matrix. So we do it by multiplying the matrices that we have here. So this multiplied by this plus this by this, and this is what we get to be equal to our output. That's our equation 3. This will multiply the whole of this, and we get this as our equation 4. So since the instrument must be correlated with the endogenous explanatory variable, it means that this x prime x, z prime z, and x prime y here will map to 0. Okay, so if this is 0 and this is 0, you're estimating for this beta cap by means of making this beta cap the subject, dividing through by this, you end up getting beta cap z to be equal to 0 on this, like s prime z. And any, if you have 0 divided by any number, you are going to get 0. So you wouldn't get the estimator. Okay, so let's take equation 4. Equation 4, z prime z is going to be 0. Then it means that from equation 4, we end up getting this equation. Okay, so you finding the estimator is a matter of you making beta x cap the subjects. So by dividing through by z prime x, and this is what you are going to get. And when you have a scenario like this, then it means that you get the covariance. So the covariance of z prime of E here will be 0. So meaning the variable and the error term are uncorrelated. So anytime you end up getting an estimator of this form, then it means that the variable and the error term, there is no correlation between the variable and the error term. That's the instrumental variable and the error term. And with this, we can be able to solve for or prove that the estimate here is what unbiased. Okay, so that's how come we had this as our instrumental variable estimator. I hope you find this tutorial very useful. Alright, so let's go to the B part of question 4. Let's move to the B part of question 4. It says that derive the instrumental variable estimator. That's 8. So that's what you derive. The B part says that we should prove for it. You should prove that the instrumental variable is unbiased. Okay. Let's walk through the proof for unbiasedness. Okay. So just as we did. So let's prove for the unbiasedness here. Okay. So you are proving the proof for unbiased. So this is what you are coming to do next. Good. So let's take equation 1. So equation 1 was giving us, y to be equal to x beta plus my error as my equation 1. Then equation 2, we had equation 2 when the variable was introduced, we had our equation 5 rather. So we are going to take our equation 5, the instrumental variable estimator, because we want to prove that the instrumental variable estimator is what unbiased. So let's take our equation 5. That's where we had our instrumental variable estimator. So our equation 5, we had our beta x cap to be equal to z prime of x inverse. Then we have z prime of what y as our equation 5. Let me wipe this bracket off so that it will just look at what we had. Good. So this is y. Good. So we have equation 1 and equation 5 just as we did here. So this is our equation 5 here. Sorry, let me make this one equation 6. Good. So this is equation 6. This is equation 6. Good. So now, this was our equation 1, and this is equation 6. So taking equation 1 and 6, okay, we are going to substitute equation 1 into equation 6. So the next step is you have to substitute equation 1 into equation 6 here. You see, equation 6 has an element of y. So we substituting equation 1 into equation 6. This is what we are going to get. So you get beta x cap to be equal to z prime x inverse z times x beta plus e. That's our stochastic error. Okay, so when we do our substitution, we put the whole thing. Anytime we see y here, we substitute equation 1 here, and this is what I've gotten. Okay, our next step is to multiply or expand the brackets here. So I see everything, this whole identity as one entity. Okay, so z prime x inverse z prime will multiply x beta, and I'll get my beta x cap here to be equal to z prime x inverse z, get z prime x beta plus this multiplying the stochastic error, this plus, I'm going to get z prime x inverse, I'm going to get z prime of the error thing. Okay, good. So now we can recall from last semester that z prime x inverse z prime x here will be equal to the identity element. So let's recall. So recall that z prime x inverse z prime of x here is equal to my identity element, in which I'm calling it I here. So I'm calling this identity element here I. I'm calling it I. Okay. So this is equal to my identity element, in which I'm terming it as what? I. So this is my identity element. Okay. So it means that my beta cap, my beta x cap here is now what? I beta, right? I beta plus z prime of x inverse z prime of what? E. And we know that any number operation or multiply by the identity element will give me the number. So for example, if I have I times a, I'm going to get a. I times 2, I'm going to get what? 2. So in this sense, I multiply by beta will give me what? Just beta. Okay, so I end up getting my beta x cap to be equal to beta plus z prime of x inverse. Then I'm going to get z prime of what? E. Okay, good. So now to prove that something is unbiased, okay, to prove unbiased, then it means that when I find the expectation of the estimator, I have to get the true parameter. So the next step is to run expectation through. So we are going to run, so you run expectation through. That's our next step. We are going to run expectation through. So I'm going to get expectation of beta x cap here to be equal to expectation of beta plus z prime of x inverse z prime of z prime in expectation of what? E. Okay, good. So now, and we can recall that last semester, expected value of a constant is a constant, but we know that expectation of a constant, which is beta cap here, will give me what B. And under the assumption of OLS, the expected value of the stochastic error here is going to give me 0. Okay, so in effect, it means that I'm going to get my expected value of this beta x here to be equal to just what? Beta. So since expected value of the estimate is equal to the true parameter, which is beta, hence I've been able to prove that the instrumental variable estimator is what? Unbiased. Okay, let's quickly walk through what I have here. So this is what I have here. So me proving for the unbiased, I substituted equation 1 into equation 5. So me, I had this equation as my equation 5. So the same thing, this is what I had here. So this is what I had here. So equation 1 into equation 6. So equation 1, equation 6. When I do my substitution, this is what I get, and it's the same as what I'm having here. Then I'll expand, and this is what you get. So we recall that this whole thing is I, the identity element. So doing your substitution, I'm going to get I beta plus z prime of x inverse z prime e. Okay. Then any number operation, the identity element will give me the number itself. So this is what I end up getting. Running expectation through, this is what I'll get. So recall, expectation of a constant is the constant. Expectation of the stochastic error is what? 0 from the OLS assumption. And this is what I get, and I've been able to prove forward unbiasedness. Okay. So that's that for our first question. So we concentrated on A, B, and what? C. So we've known the consequences of a regression model suffering from the problem of endogeneity. We've seen that it leads to what? A biased estimator, and leads to inconsistent estimator. And the characteristics that a variable should possess to qualify as an instrumental variable. We've seen that the variable should be uncorrelated with the error term, and we've proved that. And we've also seen that the variable should be correlated with the endogenous explanatory variable, and we've seen that one too. And we've been able to derive the instrumental variable estimator, and we've also been able to prove for unbiasedness. Okay, so that's the first part of this video. Okay, thank you for watching this video. I hope you find this tutorial very useful. Thank you. Kindly subscribe, share, so that we post a video of this sort, you have easy access to it.